Okay, so 2.4 is all about solving right triangles. We talked about right triangles in the past, and the picture that's at the top of the page is just a very generic right triangle where it shows you that the corresponding sides will be opposite of their angles. So angle A is directly opposite of side A. And notice that the angles are indicated with capital letters and the sides are indicated with lowercase letters. Whenever you are asked to solve a triangle, that means you have to figure out what all the angles are and you have to figure out what the length of all the sides are going to be. Usually they'll give you one or two pieces of information and then you're expected to be able to find all the others. The handout that I handed out will come at the end of the lesson. So those are the word problems at the end. So we're going to do a couple of examples where we solve right triangles. It says solve the right triangle ABC if angle A measures 34 degrees in 30 minutes and side C has a measure of 12.7 inches. And it tells us to round to 2 decimal places. So pretty much anytime I encounter a problem, I'm always going to start by drawing a picture. I'm a visual person. I like to have pictures. And I'm going to make it pretty much the same as the one, like the generic one that's up here, where angle A is down here in the bottom right-hand corner for 34 degrees, 30 minutes. And then we know the side C, which is the hypotenuse, is 12.7 inches. Outside of that, we know nothing. We don't know the measure of angle A, or we do know that. We don't know the measure of angle B, excuse me. We know the measure of angle C, because that's here. We don't know side A, and we don't know side B. So those are the 3 bits of information that we have to figure out in order to solve this triangle. But the nice thing is we know trig now, so we can figure out a lot of it. Not that we know everything about trig, I'm not saying that. The first thing that you're going to want to do, though, is you're going to want to convert this to strictly being in degrees so that we can use it with our trig functions. So 34 degrees, 30 minutes. If you remember, that's 34 degrees plus 30 over 60 degrees because there's 60 minutes in a degree, which is 34.5 degrees. Maybe you don't need to do the math or the algebra on that and you just are like, well, duh. And that's fine. I'm showing all the steps. Now that we know what this is, we need to figure out what A is, what B is, and what angle B up here is. So based on the information that I have this angle, which is 34.5, and I have my hypotenuse. So I'm going to use the sine of angle A, which is 34.5, equals what, based on our triangle? Yeah, A over 12.7, because sine is the opposite over the hypotenuse, so it'll be A over 7. Well, that's good because I can take 12.7 times sine of 34.5, and that's going to tell me how long side A is. If we type all that in, how long is side A? Approximately 7.19 inches. Because it said round to 2 places, so I'm going to round it. So now we know this side. But here's something I'm going to strongly encourage you not to do. You might be like, okay, well now I know this side and I know this side, I can come up with this side, and you can. But since we rounded for side A, if we continue to use side A to solve for side B or to solve for angle C, or angle B, we could be off a little bit because we've already done some rounding. So as much as you can, keep with the information that they gave you with to start with, is what I'm always going to recommend. There's going to be times where you can't and you actually have to find a piece of information before you can solve for another piece. But as much as possible, let's leave it if we can. Bless you. Okay, so let's find B. If I'm thinking about angle A, how would I find side B? Yeah, I'm going to use cosine, because Because cosine of 34.5 is going to be the adjacent over the hypotenuse, which is b over 12.7. So I'm going to take 12.7 times my cosine of 34.5 to get me what b is. So b is going to be approximately 10.47 inches. Who wants to take a guess at how we're going to find out what b measures, the angle of b? What do we know about the measure of triangle angles? Yeah, they got to add up to 180. So we know that this angle here is 90 degrees because it's a right triangle. We know that this one is 34.5 degrees. So if we add those together and subtract it from 180, we'll know what the measure of angle B is. So since measure of angle C is 90, then we can take all three of our angles to get 180, which ends up with 55.5 degrees. But since they gave it to me with minutes, I went ahead and converted it back to minutes. Your homework and quizzes and things like that will be very specific, and like any test I give you, it'll be specific on whether or not I want you to give it to me in degrees, or if I want you to give it to me in degrees with minutes or with seconds and things like that. In the notes, it says there's an extra example. It's solved the exact same way. I give you all the answers. I just don't do the work for you. It tells you that angle B measures 28 degrees and 40 minutes, and side A is 25.3 centimeters. So if you wanted another problem to work through that works exactly the same way where you're solving a right triangle, there's the information necessary to do that. And again, right here is actually the answers that you would be going for. So you'd be finding the measure of A, you'd be finding the length of B, and you'd be finding the length of side C. Are there questions on how we did that first right triangle? How we found any of those different parts? No. Sorry, was anybody writing that stuff down? I don't want to take it away too soon for you. Okay, I'm going to go ahead and flip over. Remember, you do have access to my digital scans for my notes. Here's another problem, and it's got a little bit of the answer up there, so I'm going to try and hide it. We're going to solve the right triangle ABC if A is 29.43 centimeters and side C is 53.58 centimeters. This one's different from the last one in that it gives us two side lengths, but we don't know angle A or angle B. So what we need to find out is we need to find out the measure of angle A, the measure of angle B, and what side length B measures. Do you want to start by finding the angles first or the side length? Side length, okay. So if we know two of the three side lengths, does anybody remember a specific theorem or anything? Yeah, Pythagorean theorem. Pythagorean theorem states that a squared plus b squared equals c squared when we're talking about right triangles. So if side A is 29.43, we can square that, add that to b, which we don't know, and then that equals c squared, which is 53 point, wow, I don't know why I wrote my 53 like that. Sorry, that looks weird. Time for some of those fancy smancy calculators. Because I don't know about you, I don't want to do 53.58 times 53.58 on paper. That's for sure. 2870.8164. And if any of your numbers ever differ from mine, please let me know. Because I'm definitely not perfect. And then to get what B actually is, we're going to have to square root that number. This one doesn't say round to 2 decimal places, but it does want you to round to 2 decimal places. 44.77 centimeters. Let me check to see if that's what I got the first time. Yep. Okay. So we can use Pythagorean theorem if we know 2 of the sides of our triangle. And it doesn't matter which 2 sides. We can use it. This time we didn't know one of the regular sides. If we didn't know the hypotenuse, we'd do the same thing. So now that we know what B is, we need to figure out what our angles are. Now again, even though we know all the side lengths now, I'm still going to use sides A and C as much as possible for finding the measure of my angles, just in case I would have made a mathematical error. If I use side B now to figure out those angles, then I'm going to get them wrong as well. So if I'm trying to figure out the measure of B, and I'm trying to use 29.43 and 53.58, what trig function would I use? Yeah, I'd use cosine because that's adjacent over hypotenuse. So cosine of B equals adjacent, the 29.43 over the hypotenuse, 53.58. Now, in order to type this into my calculator, I actually have to use that inverse function that's on your calculator. I have to use that cosine inverse of the numbers, the 29.43 over the 53.58. That's what I'm going to type in order to figure out the measure of B. And of course I did A first, but I'm going to just show you the answers. What do you get if you type that in? Cosine inverse of 29.43 divided by 53.58. You get 56.68 basically. I'm guessing by your silence the answer is yes. Okay, so again, this one didn't specify how it wanted the degrees versus minutes and things like that. It will be very specific, but based on my answers and what I put, I guess the book was asking for it in minutes. So I know that this is my degrees because that's my whole part, and then I take 0.68 times 60 in order to come up with my minutes. And when I do that, that's how I get these 41 minutes. So that it's 60 or 56 degrees and 41 minutes. Again, your homework, all the assignments will be very specific on what to round to. But once I have that, then there's a couple of different ways you can actually go about finding A. The way that I did it here in the notes was I did sine. I did sine of A, which gave me A over C. Totally fine. You work it the exact same way as you did with the cosine of B that we just did. The other way, which is actually the way I found the measure of angle B, was with using the fact that I knew that the measure of angle A and B had to add up to 90 degrees. And since I knew that fact, I took 90 degrees and I subtracted what I find for either A or B. And you can find the other one. So you can use only trig functions, or you can use some of the rules that we know about triangles and how the inside angles add up to 180. Questions on how we found A, B, side B, any of these? Just know that you're not done solving your triangle until you know the measure of all your angles and you know the measure of all your side lengths. The nice thing about the My Math Lab program is it gives you spots for all of that information. And so you're not going to be left questioning what exactly it is that you need to find, because it's going to give you 3 different entry boxes where it says side B, and then there's an equals, and then there's side C, and then there's the measure of angle A, and it tells you what to type in there. All right. We did the Pythagorean theorem first, but I did it last. So that was that one. We are going to talk about angles of elevation and angles of depression as we move forward in this class and as we start looking at different applications of what we're going to use this trig for. And yes, if you hear the word application in a math class, you need to think word problems. Or if you don't like the term word problems, you can think real world problems. Some people like that. It's the same thing. We're going to actually learn how to use this information in real life settings. And so I did make a handout. This is also, I put it on the My Math Lab site under the notes category. So if you needed another one, or if you were gone or anything like that and needed to print one off, you would have that available. And it's mostly just so we can do word problems without spending the whole class period waiting for you to write down all the words to the word problems. But the angle of elevation and the angle of depression is going to allow us to have things at different levels and talk about where they are in respects to each other. If you have an angle of elevation, then you're going to have your horizontal initial side. It's pretty much exactly like we've been talking about with our angles the entire time. The depression, the angle of depression, is where we think about negative angles a little bit because we're going in the opposite direction. So with the angle of depression, it's not this whole angle around here like if we were using regular, like if we were going counterclockwise in a normal situation. We're actually moving clockwise when we talk about the angle of depression. But regardless if you're talking about the angle of elevation or the angle of depression, it's not going to change really the math or the trigonometry that you're doing as long as you have a good mental picture of what it's asking you for. I strongly recommend on any word problem that you encounter, if you can sketch yourself a little picture, it usually helps clarify what exactly the problem is going to be asking you for. I'm going to slide it up inside the worksheet at the bottom. Because we're going to use this information about angles of elevation and depression to solve these next word problems for your handout. And I'm not a very good artist, but I will do my best when it comes to drawing the pictures. Because oftentimes the problems themselves don't come with pictures, so you're going to have to be able to read it in such a way that you can make pictures if you are a visual person that needs pictures. It says, at a point A, 123 feet away from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. Find the height of that flagpole, which I spelled wrong. So, flagpole does have an E in there. Okay, so we have a flagpole. I'm going to draw a flagpole. There's our flag. Beautiful flag, you know, because that's how we do it. So there's my flagpole. And the problem states that at a point A, 123 feet from the base of the flagpole. So here's the base of the flagpole. So I'm going to come out here to point A, which is 123 feet from that flagpole. It says the angle of elevation. So our angle of elevation works pretty much just like a regular angle. We start at the horizontal and we're going to move counterclockwise up. So the angle of elevation to the top of this flagpole is going to measure 26 degrees 40 minutes. It wants to know how tall that flagpole is. So we need to find this. And I'm labeling it a little a just because it's opposite of angle A. So what do we need to do? Huh? Yeah, tangent. Tangent of angle A would be opposite over adjacent. TOA. Opposite over adjacent. So if we did tangent of A, that would give us A over 123. Again, you're going to need to convert so that you can type in, you can't type in 26 degrees and 40 minutes into your calculator, so we do need to convert that over into strictly degrees. So if we have 26 degrees, 40 minutes, it's the same thing as 26 degrees and 40 over 60 degrees, which is approximately 26.67. So if we take 123 times the tangent of 26.67, that will tell us approximately the length of side, or the height of the flagpole, which is side A of our triangle. So the flagpole is approximately 61.8 feet tall. Again, the examples that come out of the book do not give you good examples of what to round to. But your homework and quizzes, there's always these little blue words right next to the answer box that tells you what to round to. Questions on how we did the flagpole problem. I'd say this is a really good one to know. This one's common enough to come up on exams, because I don't think it's horribly difficult, but it does show me that we can use our trig functions to solve real-world problems. No questions? Okay, let's do a depression problem, which again really isn't all that different than an elevation problem. Says, from the top of a 210-foot cliff, David sees a lighthouse 430 feet offshore. We need to find the angle of depression from the top of the cliff to the base of the lighthouse. This one, I just didn't type it. In my notes, I did specify on problem 1 to round to 1 decimal place. In my notes for this one, we're going to round to 2, or to the nearest degree, since we're talking about the angle of depression. So again, let's get out our art tools. There's my cliff, very fancy. Here's David on top of the cliff. And let's stick a lighthouse over here, offshore. There we go. Super fancy pictures, right? But we get what it's doing. So cliff, they told us it was 210 feet. We know that the lighthouse is 430 feet offshore. Notice that the cliff and the water are going to give us our 90-degree right angle. And we need an angle of depression, because what we have right here is we have this. But if we're thinking about angles of depression start at a horizontal and then they go down. But if we look at this, we don't have a horizontal per se. I mean, down here we kind of do. So you have to think about if that cliff extended out, because that's where David is. That's kind of where our horizontal is actually starting. So our angle of depression is actually up here. And you're like, okay, but that's not in my triangle. No, but we did learn about something called transversals. Like this. You guys just had a test over this. Yeah, where we have the horizontal here and the horizontal here made by the water, and it's cut through by this angle of depression. And we know that this angle then matches this angle, alternating interior angles with our transversals. That means our angle of depression up here is the same thing as the angle down here. And that is within that triangle that we were constructing with our water and our cliff. Since these two measure the same thing, now we have an opposite over adjacent. We have a tangent situation again. Where if we take tangent of our theta, it's going to give us 210 over 430. Since we're trying to figure out what theta is, we're going to have to take the inverse of those numbers, the tangent inverse, to come up with what theta is. And it says round to the nearest degree, so theta, or the angle of depression in this case, is going to be approximately 26 degrees. So what makes the angle of depression different from the angle of elevation is that most of the time we're going to have to think about using our transversals and remembering which angles are equivalent within our transversals. Whenever we're doing an angle of elevation, it's moving in the traditional trajectory and everything like that, so we don't have to worry about all of that. Are there questions about either the flagpole or about David and his cliff before we get slightly more complicated? Since you can see my words through there, I'm going to get a new one for the back. We're going to do 2 more application problems today. Number 3, I feel like, is probably the most complicated one that I'm going to give you. And the only reason why it's more complicated than the rest is because it has an angle of elevation and an angle of depression all wrapped up into one. What we have is we're going to have 2 buildings. It says from a window that is 34 feet above the street, the angle of elevation to the top of the building that is across the street is 46 degrees. And the angle of depression to the base of that building is 17 degrees. So find the height of the building and round it to the nearest foot. Okay, there's lots of stuff going on in this. So we start off with the fact that we live in this building, and we have this nice window right here. This window is 34 feet off of the ground. That's what it says. 34 feet. From that, we have another building across the street. That's what it tells us. That is a really bad 34. So let me write 34 over here. 34 feet. It says the angle of elevation from the window to the top of the next building that is across the street measures 46 degrees. And you're like, okay, but if I make that, I don't have a triangle, so I'm not sure where to put that elevation. So pretend like there is a horizontal that runs across between the buildings directly from that window. So the angle of elevation then is in this triangle that we just made, which is 46 degrees. You have to have that horizontal, and that horizontal starts from wherever it is. So for our flag one, it was on the ground because the shadow lays on the ground, and so that's where our horizontal lies. But since we're in this window that's already 34 feet up in the air, our horizontal actually lies right there at 34 feet across from that window. Now, it also says that we have an angle of depression from the window to the bottom of this same building over here. So I'm going to draw another, that's my side going down, so I have my angle of depression, and it is 17 degrees. Now it wants us to figure out how tall this black building is over here, based on just this little bit of information. Well, what we do know is that we need to figure out the height of this building. That's the unknown. But since we drew this horizontal in over here, we know that from here to here is how big? Yeah, 34 feet. So really what we're missing is what I'm going to call H2 up here. We're missing this height that goes from our horizontal up to the top of our building. Sorry, my hand's in the way. From the horizontal up to the top of the building. That's what we don't know. And we need to figure that out. Well, I don't know how to do that whenever I know the angle down here and the side down here, because I can't figure out this side length with only this measure. So what I'm going to need to do first is I need to figure out how far away these buildings are. Because if I know how far away the buildings are, then I can easily figure out how tall this part is from 34 feet up. Okay? So how am I going to do that? Well, let's be careful here, because our triangle is actually a little bit upside down. Let me draw it over here, just so it's separate. This is our depression triangle. Yeah. What we have is we have our opposite, but we're needing our adjacent. So we're needing to find out the adjacent, toe up. So you can do it a couple of different ways. You can do either tangent or you can do cotangent. Because if you remember, cotangent of a angle is what? Like in terms of O's and A's and H's. A over O. Toe. A over O. Adjacent over, yes. If you use tangent, it'll be O over A. You just have to do a little bit more algebra to do the manipulating. It's still going to work out the same way. Because what we're missing is we're missing this side. We're missing our A, our adjacent side. Cotangent of 17 is going to equal A over 34. So 34 times our cotangent of 17 is going to tell us how far apart these buildings are. One point 21 feet, approximately. So now I know that this is 111.21 feet. Oh no. There we go. So over here, let's look at the elevation triangle, just to keep it a little cleaner. We have 46 degrees. We know that this length is 111.21. We need to know what this one is. So what trig function am I going to do? Yeah, tangent. If I do tangent of 46, that's going to give me opposite over adjacent. So it'll give me H2 over 111.21. So 111.21 tangent 46 will tell me how tall the building is when we start at that 34 feet off of the ground mark. And we find that H2 is approximately 115.16 feet. So the 34 plus the H2, that's not where I want that to, equals the height of the building. So 34 plus 115.16 equals, it said round to the nearest foot, so it's going to be 149 feet tall. So for me, even though the picture up here with the buildings is nice in that you get a general picture, I almost always have to make individual triangles, and just so that I keep them straight, so that I'm not accidentally trying to find the hypotenuse when I really needed the adjacent side. And it really helps me to draw out the pictures. If you are not a visual person, you do not have to feel like you have to draw pictures. This one I think would be a little bit difficult if you didn't draw at least some picture of some kind. But if you have a method that does not require pictures, don't ever feel like you have to draw pictures just because I do. And like I said, this one's about as complicated as they get. I do know you have one of these on your homework. I think it was like the window was 30 feet off the ground instead of 34 feet off the ground. But it's a very similar process. Are there questions on this one? Okay, no questions. Let's move on to the last one. The length of the base of an isosceles triangle is 30.14 inches. So an isosceles triangle, if you remember, looks kind of like this, where two sides have the same measure. That's an isosceles triangle. And this time they told us the base, so that's the bottom, has a measure of 30.14 inches. Each base angle, so that's these bottom two, which are always equal, have a measure of 35.08 degrees. Find the length of each side of the two equal sides of the triangle. So what we're needing to know is we need to know what this is and what this is. And they were even nice enough that they kind of give you a hint. It says cut the triangle into two right triangles, because this whole section is titled application problems or solving right triangles, but we don't have a right triangle, we have an isosceles. But if we drop a bisector down like this, then what happens is we just cut our isosceles triangle into two right triangles. So I'm going to do half of it over here. Where this is our right triangle, this is 35.08 degrees. This is what we don't know. And if I cut the base in two, then what is the measure of this side?
It's going to be 15
Yeah. Because if I cut it straight in half, then each of these triangles is going to be half of the 30.14. So now I need to figure out what this hypotenuse is, because that's going to tell me what that side length is. So what trig function am I going to use? Yeah, I can use cosine, because cosine deals with adjacent over hypotenuse. Now we're going to have to do some algebra because the x was on the bottom. So if I move it over and then divide by the cosine, I know that x is going to be the 15.07 divided by the cosine of 35.08. This one did not specify, at least in the words, but let's round to 2 decimal places. We find that x is approximately 18.42 inches. So each of these side lengths is going to be 18.42 inches. So sometimes they're not going to start you off with a right triangle, but you can make a right triangle if it's in this section. Because that's where we use our Pythagorean theorem and our trig functions in order to solve these application problems. Questions on any of these that we did? Yes, maybe.